Alright, so we're going to start in today on the converse of the Pythagorean theorem. You have heard of the Pythagorean theorem before, and we're going to start with that review, and then we'll get into what the converse is. So the first thing you need to know is what a right triangle is. And remember, that's just a triangle that has one right or 90-degree angle. So it'll have that little box, it'll say 90, something like that. So here's your general drawing. You have a right triangle here. Remember, it is right because of this right angle right there. And I labeled the sides with A, B, and C. We're going to kind of talk about that now. So A and B are what we call legs. And C right here is always called the hypotenuse. So there are two things you need to know about the hypotenuse. First, it's always across from the right angle. And then the next thing is that the hypotenuse, that one that I have labeled as C, is always the longest side. So keep those two things in mind as we're moving forward. So now we're getting into the actual Pythagorean theorem, and remember, that's your a squared plus b squared equals c squared. And then remember also, just from that drawing, we already talked about it, a and b are the legs, and c is the hypotenuse. So we can and we do use this when we're looking for the missing third side of a right triangle. So this can be used when you're given two sides and you're missing that final third one. So we're now going to talk about something called Pythagorean triples. So this is a special patterns of right triangles that fit a squared plus b squared equals c squared. They're sets of three numbers that make that true always. So some of these include 3, 4, 5, 5, 12, 13, 7, 24, 25. There's plenty other. They also include all the multiples. So if I was to multiply this first one by like 2, I would end up with 6, 8, and 10. 6, 8, and 10 are also a Pythagorean triple because they're a multiple of that 3, 4, 5. Alright, so the example here is we're going to find x. We have a right triangle, so that's good. And the next thing we notice is that we have two of the side lengths. That means that we can use our Pythagorean theorem. So we have a squared plus b squared equals c squared. I'm going to go ahead and label my a, b, and my c. Remember, A and B are your legs, so it doesn't matter which one's A, which one's B. What does matter, though, is your C. It has to be the hypotenuse. It has to be that side across from the 90-degree angle. So I'm going to start filling stuff in. My A is x, so that means A squared is just x squared, plus my B is 6, so B squared is 6 squared, and it's equal to my C is 10, so 10 squared. I don't know what x is, so I'm going to leave it as x squared plus 6 squared. Remember, that is 6 times 6. So 36 is equal to 10 squared, so 10 times 10, 100. I want to solve for x, but first I need to get the x squared by itself. So I need to move this 36 over. In order to do that, I'm going to subtract 36 from both sides. It cancels out on the left side, and I'm left with x squared equals 100 minus 36 gives me 64. I'm now going to take the square root of both sides because it undoes it. So if we had something like 2x equals 8, we would divide because it's the opposite of multiplication. Here we need the opposite of taking the square of something or squaring something, so we're going to take the square root. What that leaves me with is x is equal to 64 is the square root is 8. So I know that x is equal to 8, which is just c is equal to 8. So here my hypotenuse is 8. We talked about those Pythagorean triples up earlier, and if you had noticed it was a Pythagorean triple and you knew that that side was 8, that's cool, that's fine. If you don't, you can always use the Pythagorean theorem. Alright, so example 2, we're going to find x again. You have 7 and 3, so I can use the Pythagorean theorem, and it is a right triangle. This one's a little different though. So I'm going to label my legs as A and B. And then my hypotenuse is C. Remember, your Pythagorean theorem is a squared plus b squared equals c squared. Now I'm going to start plugging stuff in. My a is 7, so 7 squared, plus my b is 3, so 3 squared is equal to c squared. The last one, we were looking for a leg. Here we're looking for the hypotenuse. These ones are a little bit easier. So 7 squared is 7 times 7, which is 49, plus 3 squared is 3 times 3, which is 9, is equal to c squared. I can combine these two together. 49 plus 9 leaves me with 58, and it's equal to c squared. Remember, we had like x squared, something like that on the last one, and in order to undo that, we did the square root. We're going to do the same thing here. you're going to take the square root of both sides, and that leaves me with c is equal to the square root of 58. For right now, we're going to leave them like this. In the future, we will reduce these radicals. So your next example is a word problem. You're going to see these a lot, and these are where you're going to get into trouble. So it says, a ladder is leaning against the side of a 10-meter house. If the base of the ladder is 3 meters away from the house, how tall is the ladder? So here you need to make sure you are drawing a picture and showing your work. So the first piece of information we get is that it is leaning against the side of a 10-meter house. So what I'm going to do is I'm going to draw a line. Your houses are going up and down just like this, and I'm going to say this is the house. This is 10 meters long. And there's a ladder leaning against it, so I'm going to say that my ladder is leaning like this. And I know the base of the ladder is 3 meters away. So remember that base, that's the bottom of the ladder. This distance right here is 3 meters. And I'm asking you to tell me how tall the ladder is, how long the ladder is, anything like that. Those mean the same thing. I don't know what it is, so I'm going to call it X. Now, because this is a house that is up and down, which is vertical, and then the ground, of course, is horizontal, I know it makes a right angle. So I now have a right triangle. I have 2 side lengths, and I can use the Pythagorean theorem. So again, I'm going to label my sides as A, B, and C. So I know my legs are A and B, and my hypotenuse is C. So for the Pythagorean theorem, A squared plus B squared equals C squared. My A here is 3, so I have 3 squared plus my B here is 10, so 10 squared is equal to, and my C is what I don't know, so it's X squared. I can simplify 3 squared, 3 times 3 is 9, plus 10 squared, 10 times 10 is 100, is equal to X squared. 9 plus 100 gives me 109, and it's still equal to X squared. Now to get X, I take the square root of both sides. Remember, we're going to leave it just like this for right now. The square root of 109 is equal to X, but remember that X was actually C. So C is equal to the square root of 109. So this example here, I'm asking you, what is the length of the diagonal? And it's that slanted line. So if you look here, this actually looks like 2 right triangles put together, and that's all it is. So I'm going to label my sides. I know that the X is across from the 90-degree angle, so I know that's my C, which means my other 2 side lengths are just A and B. So I know I can use my Pythagorean theorem, A squared plus B squared equals C squared. And I can start filling in that information. I labeled A as 40, so 40 squared plus B for me was 30, so 30 squared is equal to, and then that C is X, so X squared. So when I multiply it out, 40 times 40 gives me 1,600. 30 times 30 gives me 900, and it's equal to X squared. 1,600 plus 900 leaves me with 2,500 or 2,500. And then my last step here is to take the square root of both sides. When I do that, though, I get 50 is equal to X. Remember, C was X, so C is equal to 50 as well. This one is important to note that this was a 3, 4, 5 multiple. If I multiply 3, 4, and 5 by 10, I get 30, 40, and 50. So if you saw that and you automatically knew C was 50, cool. If not, use the Pythagorean theorem. So we're now going to get into something that we call the converse of the Pythagorean theorem. All of this before this should have been a review. This is the new information. So we still have A squared plus B squared equals C squared. And if this ends up being true, so if A squared plus B squared is C squared, then it is a right triangle. That's what we've learned so far. That's what we've known. That's what we practiced. But we can also use the Pythagorean theorem. We're going to actually use the converse to determine if a triangle is acute or obtuse. So remember, if you do the Pythagorean theorem and A squared plus B squared equals C squared is true, if the left equals the right, if it's 20 equals 20, whatever it is, that means it is a right triangle. Now, if A squared plus B squared is less than C squared, this would give you an obtuse triangle. And finally, if A squared plus B squared is greater than C squared, this would give you an acute triangle. So there's something that I need you to remember. in these problems, you're going to be given 3 side lengths or a triangle with 3 sides, something like that. You're going to have to check it to see if it's a right, obtuse, or acute triangle. But you need to always check to see if the side lengths can even make a triangle. So this is a little weird right now. I need you to think the opposite when you're using these for acute and obtuse. If something is less than, you kind of think small, but I need you to think big. Remember, obtuse are the big angles. So if you get the less than, then it's obtuse. Same thing with this. Greater than is usually big, but with Converse, you think the opposite. So if it's greater than, it's acute. All right, so your first example is 3, 7, and 9. So I would ask you something like classify this triangle, and that's all you get is the numbers. So the first thing we have to check is it a triangle? So I'm going to take my 2 smallest sides, 3 and 7. I need to add them together, and they have to be greater than the largest side, which is 9. So 3 plus 7 does give me 10. And 10 is greater than 9. So yes, this is a triangle. I know that for sure. So I can give it a check mark. Now we need to plug it into our Pythagorean theorem. So I have 3, 7, and 9. And you're like, I don't know which one's A, which one's B, which one's C. But you do. You know that the largest side is always C. So I know that 9 is C for sure. And then the other 2 don't matter. They're the legs. Either A or B is fine for the other ones. I'm now going to go ahead and plug it into my Pythagorean theorem. A squared plus B squared is equal to C squared. So A, I labeled as 3, so 3 squared, plus B, I labeled as 7. 7 squared is equal to, and my C I have as 9. I'm going to go ahead and do the simplifying. 3 squared, remember, is 3 times 3, which is 9, plus 7 squared is 7 times 7, which is 49. And it's equal to 9 squared, which is 9 times 9, or 81. I can simplify some on the left. 9 plus 49 is 58. I still have this 81 here, so I'm going to drop it down. I now have to compare the 2 numbers. So I have 58 and 81. I know that 81 is bigger than 58, so I'm going to put a less than symbol. Remember, the open side should go towards the bigger number. When I look back up at my Converse of Pythagorean, I have the left is less than 81. So looking up here, the only one that looks like that is this middle one, where the left side is less than the right side. That tells me I have an obtuse triangle. Remember, I told you to think about the opposite. So since this is a less than sign, I want to think small, but I need to think actually big. So I know that this is A squared plus B squared is less than C squared, and because of that, I know this is an obtuse triangle. So example 2, I have 20, 29, and 21. So remember, the first thing, I take my 2 smallest sides, 20 plus 21, and I need to make sure it's greater than my biggest side. So 20 plus 21 gives me 41, and that is greater than 29, so I can continue on. I'm going to go ahead and label my sides. My largest side is 29, so remember that's your C. And then A and B don't matter after that. So I'm now going to plug this into the Pythagorean. A squared plus B squared equals C squared. I labeled A as 20, so 20 squared plus my B was 21. 21 squared is equal to C, which for me it was 29. I'm going to go ahead and start simplifying this. 20 squared gives me 400. Plus 21 squared, or 21 times 21, is 441. And it's equal to 29 squared, or 29 times 29, which is 841. I simplify the left side. 400 plus 441 gives me 841. And I have 841 on the right. So these are equal to each other. So what just happened is I have A squared plus B squared is equal to C squared. And because of that, it tells me I have a right triangle. So remember, we're using that list on the last page, this one right up here. You're comparing it. If it's equal, it's a right. If it's less than, it's obtuse. If it's greater than, it's acute. So example 3, I have 4, 11, and 16. Remember, we take my 2 smallest sides. So 4 plus 11 is greater than 16. 4 plus 11 is 15. And so right now I have 15 is greater than 16. This is not true. So this is not a triangle. We can't do anything else with it. We're not going to plug it in. This is really important because if you don't recognize that it's not a triangle, you are going to get the wrong answer. So the last example of this section we have 17, 17, and 22. So first things first, we're going to check our two smallest sides and add them together and see that it's greater than the largest side. So 17 plus 17 is greater than 22. That 17 plus 17 gives me 34. And 34 is greater than 22, so I know it's a triangle. I can now go and say that 22 is my C because it's the biggest side. And then, of course, A and B don't matter. They're both the legs. So I'm now going to plug this into the Pythagorean theorem. A squared plus B squared equals C squared. My A here was 17, so 17 squared, plus my B was also 17. 17 squared is equal to my C, which is 22 squared. When you plug it in, 17 squared or 17 times 17, it gives you 289, plus 17 squared again is 289, and it's equal to 22 squared or 22 times 22, which is 484. Again, you simplify the left side. 289 plus 289 gives you 578. I still have 484 on the right side, so I need to compare these numbers. I have 578 and 484. I know that 578 is greater than 484. So what I have here is that A squared plus B squared, that's the left side, that was this 17 squared plus 17 squared, is greater than 484. So I want to think the opposite. Greater than makes me know that this is an acute triangle. So you have these notes today. You also have practice problems. Make sure you get them, the practice problems turned in and submitted as soon as possible. Any late work will only have one day to be checked, so please get those in as soon as possible.